Hello, welcome to this video. I will give you a short introduction how to analyze multimodal image datasets, in particular PET-SPECT-CT data using the Imalytics Preclinical software. I will explain how to investigate your image data, then perform organ segmentation based on the PET or SPECT intensities, and how to use our dosimetry tool to calculate important parameters such as the cumulative dose or the projected dose. I will open the software first. I will use version 3.1.4 of the Imalytics Preclinical in this video. Then I go to Tutorials, PET-SPECT, PET-SPECT-CT, Load Example Dataset. And because the Imalytics Preclinical is meant for multimodal image analysis of preclinical image data, we have several multimodal image datasets implemented in the software for training purposes. So you can find them under Tutorials, PET-SPECT, and you see here that we have different example datasets. You can open the dataset and then you can play the video and practice on the respective example dataset. Okay, I have here the 2D slice views, and to investigate my multimodal image dataset, I open this 3D rendering. I will rotate it a little bit and zoom out. And what we see here is the CT scan of a mouse that was injected with 3 tracers, with FTG, with Iodine and Technetium. And when we open the software, the underlay is selected. And a short reminder, in the Imalytics Preclinical, we are able to load one underlay. And the underlay is normally the image data that provide anatomical reference, such as CT dataset or an MRI image. And you can find the information here. So here's CT and Hansford units. Now I go to the overlay. In the Imalytics Preclinical, we are able to only load one overlay, but we have the option to have several channels. So we have here channel 1 out of 3, and as overlay we have the PET and SPECT signals, and the first channel shows the FDG signals. Now I go to the second channel. We have here iodine in green. I will hide the underlay that you can see the signals a little bit better. So here in green we have an accumulation of iodine in the thyroid, and the third channel is technetium, and technetium accumulates in bones and in the liver. Now let's go back to FDG. I will show the underlay again, and I will close the organ segmentation under classes, delete all classes, because I would like to show you how you can simply perform an organ segmentation using the PET and SPECT signals. But maybe it's important to mention, before you perform some segmentation or image operations, it's important that you have only one mouse for the analysis. So in this example dataset here, we only have one mouse, but maybe you're using mouse holders for your PET and SPECT studies, where you scan 3 or 4 mice at the same time. And we recommend to perform then some pre-processing on your image datasets, so to crop out one mouse, to really focus for the analysis on one mouse. Otherwise your datasets will be too large and the analysis and segmentation operations will take too long. So for the pre-processing, I recommend to watch the videos mouse mode and cropping. There the image cropping is explained. Or when you go to PET-SPECT, dosimetry analysis, there a lot of information are given about the pre-processing of your image datasets. So if you have any questions, feel free to watch those videos. Okay, but now I will start with the organ segmentation, because we have only one mouse here. So I will segment the kidneys first. I zoom in a little bit, then I go to a slice where I have a strong kidney signal. Now I change my selected layer from underlay to overlay, because I want to use the FDG signals for the segmentation. I go to the ISO tool. We have a tutorial video explaining also the ISO tool and how it's working. So feel free to watch the video if you have some more questions about it. I will add a class kidney, and now I will start segmenting the kidney very fast. One kidney, next kidney segmented, Now I will also use the heart signals for the segmentation of the heart. I add a class heart, and I have the heart segmented. I will go to the other channels. Here we have the iodine signals. I could also segment the thyroid, but I would like to segment the liver now. Using the Technetium signals, I will add a class liver. And now I have the liver segmented. That was too much. I can always use the function undo if something's not correct. And now what I can do, you can get some statistics under statistics, class statistics, selected layer. You see the channel index is 3, so we have now the statistics for the Technetium. We get the volumes as well as mean and total. And as I mentioned, this is specific for the tracer, so when I go to FDG, I get the statistics for the FDG scan. Okay, now I would like to show you our dosimetry tool of the Imalytics Preclinical. And for the dosimetry tool, I need different time points of the same mouse. So I will load another example data set because this example has only one time point. I will drag and drop the statistics data, so underlay, discard. Now also the SPECT signals as overlay, and I will load an organ segmentation. We have here a mouse that was injected with a SPECT tracer and it was scanned at several time points. I will use the batch mode, set batch settings. Here you can see the time points. We have 4 hours, 24 hours, 48, 72 hours post-injection. If you have questions about the batch mode, go to tutorials, general batch mode, and watch the video about it. It's very helpful. Now I can go through my scans using F10. So this is the previous time point. You see here 48 hours and now 24 and now 4 hours. And we see that the mouse has a tumor, so we can also calculate the cumulative dose and projected dose in the organs here, in the tumor, in the muscle, in the kidney, lung, liver, and I think heart as well. Let's check. Not the heart. It was not segmented here. Okay. So what I have to do before I can calculate everything, I have to go to models, nuclear, and then convert %ID per ml because, when I go to overlay, you see that my units are in SUV. So I have to perform this conversion first. But the software will also tell you. So when you try to compute a single dose map, the software will tell you that you have to perform the calibration first. And this is what I do now. %ID per ml calibration. You can see here the metadata. We see here that the isotope was lutetium-177. You can adjust your metadata if they are not correct. Just enter the correct metadata, then set metadata, and then you can change them. But in this case, I think they are correct, so I go to apply scale factor, and now everything was converted to %ID per ml. I can adjust the windowing settings as mentioned by the software. Okay, so in this way the dose map was calculated, and what I have to do now, I have to do it for all the different time points. I did this already before, so I will load the dose map and then just set the batch settings again for all the time points. And now you can go to modules, nuclear, dosimetry, compute cumulative dose, and it's computing. It takes a while, and now we get a huge table with one row for every organ and every time point. And Yes, to see the visualization, you can go to dose weight profiles, and we see here on the x-axis is the time, and on the y-axis is the dose weight in milligray per second. And you can see that the signal in the tumor is increasing until the 3rd day, and then it's decreasing. And the shape of the curves for the bladder and for the kidneys, for the liver is different. So they are high at the beginning, and then they decrease. And yes, here under cumulative dose statistics, you can see the cumulative dose. So this is the integral, it's the area under the curve. And this is the overall absorbed dose. For example, for the tumor it's 7, for the kidney it's 11. However, your damage by the radiation, it doesn't stop when you stop scanning. So that's why we extrapolate with the software also the later time points. So this is the dotted curve, and this is calculated here. We call it projected total dose. So for the tumor it's 16, and for the kidney 18 and 12 for the liver. And yes, you can save everything to Excel or to ODS to further process it and for further analysis. And this is how our dosimetry tool works. So let me summarize the approach for you. The initial result what you get from a scanner are your PET or SPECT data, for example in megabecquerel per ml, and then what we do, we first perform a conversion to % ID per ml with the Imalytics Preclinical software. Then we calculate a dose weight map. Then we can perform an organ segmentation based on the intensities, for example, as I showed on the example before, and then we calculate the cumulative and projected dose. Okay, I hope this helps. Thanks for watching. Bye bye.